Hey everyone, it's Tuesday, 3 o'clock. That means it's Tech Tuesday. So it's been a little over 10 years since World IPv6 Day when it was announced that people would start moving forward in a concerted effort to start doing IPv6 in their networking on the internet. And we're still a long way before we are completely IPv6. I'll be discussing that. Be right back. Thanks for joining me. Rick Husey here with Tech Tuesday. So just was thinking about this the other day because I've been reading up on some articles that were talking about the fact that we still don't have an IPv6 network. So again, it was this. If you look back here, we had in 2011 we had World IPv6 Day. That was it says a 24-hour test. So that was when entities just tested IPv6, made sure everything was working, and then about a year later, June 6th in 2012, so 6/6 IPv6 6/6 2012. They then went ahead and did IPv6 launch day, World Launch Day. So that was meant to say that all of these different stakeholders, operators. So you can read that. It says thousands of website operators, network operators, and device manufacturers came together to declare that IPv6 is the new normal and that their sites, networks, and services would operate over IPv6 from that point forward. So, these were some major players that had committed to do this. You see here, it says, in the years since the 2012 launch, the growth of IPv6 usage continues at a strong rate. So it has grown and continued to grow at a rate, but I think many probably thought it would be, maybe we'd be done with all of that by now, but that's not been the case. So I was looking at some charts here. So this does show you that it's been a consistent trajectory of growth. This is back 2010 here, 2020. So if I scroll this back to that time frame during that launch, if I can get that, grab that. So we're looking here. So this again is like around June 2010, and there were if you look up at the top here, you see, I got to scroll over here to get to that, but you see native IPv addresses, IPv6, and you've got the 6 to 4 kind of conversion, which apparently that's something, that particular type of conversion is no longer being used because it goes to 0 pretty quickly. Then you've got total IPv6. So really the total and the native become one and the same pretty quickly here as we look at that. So, but anyway, so you can see here, this was what was going on. You've got June 2010, then you've got June 2011, right about here. So this is really where that World IPv6 launch was, and you can see it. From this point on, again, it was growing at a pretty good clip there, almost looking exponential at one point. But while it continues to grow, we're still a long way. So you're seeing here. Here about this point, 2020, we have, again, you see the native and the total IPv6 are the same, one and the same as you get to this point of the chart. There was just some minor differences down here. So here you're seeing 2020, we've got about somewhere around 30% native or total IPv6 use. And then right around the pandemic, it's interesting that there's this sudden change here in the chart, and I don't know exactly what that means because it's kind of the bottom end of the chart, and I'm not sure exactly what I'm looking at here. So, but obviously that did impact some things. It actually looks like it increased the total usage because we went from again, we were at about 30 here, and then dropped down a little bit, and then right about here, which was March 2020, this is pandemic time. Then you've got drops. It goes to 29, 28, but then 31. So yeah, I don't know. But it seems like the bottom portion of this chart dropped out. I'm not sure what that means, but in any event, that may have been something pandemic related. But again, it continues on an overall straight line trajectory up here. A little bit, you've got your dips here and there. So this would be maybe some operators that are expanding, but they decide to purchase IPv4 addresses instead of going IPv6. It could be that. Then you've got, increases that could be greenfield operators that are starting up with IPv6 only, or IPv4 operators that are going completely IPv6. So I'm not sure what the ups and downs are, but you see it, again, pretty much a straight trajectory here. And then we're up about 40%, 42%. Then again, dips a little bit. And again, about 41%, looking at January 29th, 2023. So this chart's tracking things. If I go up here, whoops, that scroll actually moves my chart. Hold on here. Let me go back to that, and I got to use my bar here. There we go. So you can also look at per country IPv6 adoption. And this is based on, again, I didn't mention it, I guess, but this is Google's data. So assuming this is looking at just traffic that Google is noticing and processing. So you see here, you've got the US at 45.88%, it's almost 46%, Canada 34%. Down here, you got Brazil about 46%. Argentina, 15%. So it varies obviously by country. You got Nicaragua, 20%. I guess Mexico is at 44%. Then you got France. They're always pretty high for some reason. You got 74% here. India on this particular chart is 70% approximately. This is Turkmenistan, which is reporting nothing. I don't know if that means they have nothing. Not sure what that means. Then you've got Saudi Arabia right there at 60%. Not a whole lot here in Africa. You can see that's a big area where there's not much going on. You got Australia at 31, approximately 32%. Japan at 46%, almost 47%. So that's looking at it from Google's perspective. Then you've got Akamai that also is tracking this by country. And the numbers are slightly different in places. So this may be depending on the traffic that Google is seeing versus Akamai and what they're looking at. So I think if I remember, they're caching kinds of technology and servers that they have around that traffic is flowing through them. And then you've got Google where they're seeing, I guess, traffic that they are looking at maybe through their search and I don't know what else. But if you look at the numbers here, you've got the US at 53.2%, so a little bit higher than we saw on the Google one. You've got Canada at 38. Again, you got Brazil. So you're going to see basically the same kinds of countries that have got the higher levels, just maybe slightly different percentages. Because again, you got France here. They're 60% instead of 70% there. You've got, let's see, India. India was this one's quite a bit lower. So 44% versus, I think they were like 70% on the other map. Then you've got let's see, we got Iran, 5%, but then you got Turkmenistan just above Iran, which is just blank. So again, it was like practically nothing on the other one, and here there's just nothing there. So I'm not sure what that's about. You got Australia, 29%. What were they on the other one? Australia, so 31.5. So it's very close in that case. But like I say, India, here you got about 70% versus here on this one, you've got 43, almost 44%. So I'm not sure what the difference is there. But you can see adoption rates for IPv6 definitely varies by country. So there's still a lot of countries out there that are not doing much with that. So what does this all mean as far as our future? Because really there's a struggle here because IPv4 and IPv6 are not really compatible. IPv6 is not backward compatible to IPv4. So what you have is we're having to use IPv4 and IPv6 because you have people that are on IPv4, broadband subscribers that need to be able to reach IPv6 content, and you have people that are on IPv6 networks with their internet service provider that need to be able to reach IPv4 content. As you can see, there's a lot of IPv4 content around in various places. Even in the US, again, we're only at 53% adoption according to this. Now, some of that is, subscribers that, what kind of IP address do they have? Is it 4 versus 6? But it also could be websites, web hosting providers that, what is the network that is supporting that website, and what is the web server? Is it IPv6 or IPv4? So that's the challenge. There are a couple of options for internet service providers, for broadband providers. So if you're a broadband operator, one of the things that you need to know is that you have to have an IPv4 address for every single subscriber that you have. Let me take that back. You have to have a publicly routable IPv4 address for every subscriber that you have. You don't necessarily need an individual IPv4 address for every subscriber, and I'll mention why that is the case in a moment. But what that means is even if you are starting up your broadband service, so if you're brand new and you're going to be rolling out you just got federal money and you're going to be rolling out fiber in a particular area, and you're thinking, well, I'm just going to set everything up IPv6. Well, yeah, that would be the way to go, is to obviously set up your network with IPv6 and make sure that all of your subscribers have IPv6 IP addresses. But unfortunately, they all need an IPv4 address or access to one. They all need access to a publicly routable IPv4 address to be able to reach all of the content and other networks on the internet that are not yet IPv6 ready. So that is the challenge that we have. And back around, I think it was 2015 or so, ARIN, the American Registry Internet, one of the regional internet registries, and then you've got others like APNIC, APNIC, and RIPE in Europe, and some others. They all basically have run dry of IPv4 addresses. So some of them are putting people on wait lists. They're saying, if you have a need for IPv4, we'll put you on a wait list. But for the most part, what's happening is those that need IPv4 addresses are either leasing them or buying them, and in most cases buying them from a broker. So there are, as IPv4 addresses get turned back in some cases they get turned back into the registry. And in some cases, they just get, the people own those addresses, and they will sell those. They'll have a broker and they'll sell those addresses. And the prices of those have gone up quite a bit. They started when they first became available for purchase, back when, ARIN and others said, hey, we're not going to be giving you additional addresses unless there's like an emergency or something like that. In the early days, then the prices were like $8 an IP address. Well, now, if you look around and you see what they're charging, it's 50, 55, 60, 65 per address. If you get, let's say, a Class C, it can go down if you get a huge number of addresses, but not by that much. So the price per IP address, IPv4 address, has gone up. And again, you need access to a publicly routable IP address for every single subscriber. So there are two options now, and one of them is to buy an address for every subscriber. So again, if you were going to get in the business, and let's say you're going to start out with having, you're starting and you hope to have maybe 2,000 subscribers in a year, then you're going to need to have access. You're going to either need to purchase 2,000 IPv4 addresses plus more for growth, or you're going to need something like carrier grade NAT to be able to purchase fewer addresses and then be able to do network address translation. That's carrier grade network address translation, carrier grade NAT or CGNAT, in order to have access, so that every customer can have access to an IPv4 address, even if everyone does not have their own IPv4 address. So that, in my opinion, is the way to go, because we can see here, even though the growth trend looks pretty good, again, it's on this trajectory here. We're still less than 50%. And this is after how many years here? So you got, again, starting, let's say, 2012 for IPv6 World Launch Day up to now 2023, we're still under 50% on IPv6 deployment. So it could easily be another 10 years, if not longer, for IPv6 to take over. And it almost seems like there needs to be some kind of a deadline, and maybe somebody will consider doing that in the future, where, when I say somebody, I mean, the internet registries and governments will get together and say, we need to get off of IPv4. So everybody's got to plan on doing that. I have a feeling, though, it's going to be more about just the technology changing, and equipment finally needs to be upgraded. And when the equipment finally needs to be upgraded, then people get the equipment that can support that, and they're forced to deploy IPv6. It seems like that's going to be more what happens. So again, it could be 10 years out before any of that happens, or longer. So again, one option is to buy IPv4 addresses, but that's not really a good long-term plan, in my opinion, because we're trying to add more and more subscribers. We're getting federal money to get more broadband customers. There are going to be broadband operators that are going to be growing, and as you grow, that means for every customer that you add, you would need to buy an IPv4 address. So it can get very expensive very quick. So another option is carrier grade NAT, and we actually offer a carrier grade NAT solution. It's a software-based solution, so it's less expensive than you might find if you're going to buy a piece of proprietary carrier grade NAT hardware. It's something that can run on standard x86 hardware. But the software, so it's a virtualized software. It can run in a virtualized environment, but also just on a server or set of servers for redundancy. And it's a way of doing NFV, basically, network functions virtualization, using carrier grade NAT. So We have a ROI to just give you an idea of how it doesn't really make sense to buy IPv4 addresses. So on here, I just have kind of a couple of examples. This would be like a smaller internet service provider. And these are the folks that, their budgets are going to be the most restrained or constricted as far as being able to purchase IPv4 addresses, but it might make sense for them to do a capital outlay of carrier grade NAT, for example. So if you look at a provider that might have 10,000 subscribers, and let's just guess that they have maybe 12,500 IPv4 addresses. So they've got a little bit left over. But if they are priced at, let's say, $55 per IP address, which again, if you look on the market, that's about where they are, a little bit lower, a little bit higher, depending on where you go. And then let's say they grow 15% a year. So in the first year, in that scenario, they've got enough IPv4 addresses to cover their growth. So their future subscribers are going to be about 11,500 if that's their growth pattern. But by year 2, they've grown past the number of IPv4 addresses that they have, and they're going to need to add another 725. So they're talking about that at $55 a piece. They're talking about $40,000. And then year 3, you can see it just goes up from there. So if they continue to grow at that clip as they maybe expand their service area and add subscribers where they are, then after 5 years, you're looking at $418,000 in purchasing IPv4 addresses. And again, if you look at the growth pattern and the trajectory, it's going to be quite a while before you're not going to have IPv4 addresses, because your subscribers are still going to need to reach IPv4 content. So, but then if you look at it with carrier grade NAT, plus the cost of any IPv4 addresses that you would need, really, if you enable carrier grade NAT, you can do something relatively conservative. You can do a 64-to-1 oversubscription, meaning that for every one IPv4 address, publicly routable IPv4 address, you can have 64 subscribers that are sharing that. Carrier grade NAT can handle that. And that's not unheard of. I mean, we've got people doing over 100, I think 128-to-1 over subscriptions. So if that's the case, then you really aren't going to be buying any more IPv4 addresses anytime soon. So you could handle up to 800,000 subscribers doing that kind of an oversubscription ratio. So you see there's no cost for additional IPv4 addresses in that case. So that's 0. And then you do have your estimated cost for getting carrier grade NAT. And again, with a solution like ours, where you've got kind of off the shelf hardware, it needs to be good hardware, and you want to have redundancy built into that, where you've got 2 servers instead of 1, if you're doing it that way. Then you're talking about $42,000 outlay. So in your first year, in this scenario, you're having to put out some money. But by year 2, you're about breaking even, so 40,000 roughly to 42,000, but it really goes up from there where it makes a big difference. And that's, again, assuming that you've got that much buffer in IPv4 addresses. This changes, obviously, if I go in here and I make this, you've only got 11,000. Oops, I forgot my, there we go. Can't use my number keys in here. Things are going to start happening on my screen. So you can see right there, that changes things a little bit as we then go to, did that change? I think it did. Let me see. Gotta quit doing that. Hang on here. So let me go this way. 12,500. Oh, now, I've had a problem with this thing. When I make this big, it just stops working. So I can't put my numbers in here, but I'll go ahead and post I haven't put it in there yet, but I'll post in the description a link to some of these sites, including this ROI calculator if you want to look at that. So as as these numbers grow, as the number of subscribers that you have grows, obviously these numbers start to get crazy as far as what it costs to do IPv4 addresses. And obviously this is going to go up as well, but it is a similar kind of scenario where over time, and sometimes even from the first year, depending on how many IPv4 addresses you have, it makes sense to get carrier grade NAT. And even in this scenario where you're going to have to do a capital outlay of roughly $42,000 in your first year, it makes sense pretty quickly, because you don't want to have to pay $148,000 in year 3 when you could still be running off of your original investment right here. Now, eventually, you need to upgrade. In our particular scenario, you might have to upgrade your equipment. And you also might have to upgrade your license because that's based on throughput, but you can still see it's well worth it. Let's say $418,000 versus $75,000 if you're going to do carrier grade NAT. So that certainly makes a lot more sense to do it that way. So again, I will post a link to this ROI calculator so that you can check that out. But again, if you think about it, this is something that every operator needs to be thinking about now, because I think what's happened is with a lot of service providers is they don't want to make the decision. So they just buy a few IP addresses at a time. So they're making that outlay. It's not a permanent kind of a solution. So they keep buying IPv4 addresses, but they're really, as time goes on, again, it could be another 10 years, you're going to be constantly buying those addresses, spending way more over time than it would be to just go ahead and move over to carrier grade NAT. And there are a lot of preconceived notions about carrier grade NAT. Well, it doesn't work with certain applications, and how do you handle law enforcement situations where you need to find an IP address for somebody who was using it. There's really good logging now to be able to do that, where you can actually find that information, and there are more and more applications that natively support carrier grade NAT. Plus, if they don't, there are application, I forget what they're called, application, basically hooks that you can put in that will handle certain applications like gaming and those other things. So those are not really issues. So you've got those kinds of things. And you can always, if you've got a particular subscriber that needs to have their own IPv4 address, you can do that. You can assign those, but you want to minimize that. But you would do that for those subscribers that have maybe a particular application or situation where they need to have a dedicated IPv4 address for themselves and nobody else is using. That can be done as well, just by doing a static IP kind of arrangement for them. So anyway, IPv6 looks like it's going to be a while before we're all that way. There's going to be a lot of IPv4 only content out on the internet for a long time. So just be aware of that. Again, this is something that's applicable to a current internet service provider that you find yourself just constantly going back to the well and saying, okay, we got to buy more IPv4 addresses, we got to buy more addresses, etc. You might want to consider looking at carrier grade NAT, because again, it's a mature kind of product now. And again, with a solution like ours, it's much less expensive than you might have seen if you were looking at big proprietary iron that you would have, a big hardware in your back room. In this case, it can, again, off-the-shelf servers, the software, and it's much more affordable. So you should look at it for that reason. And then also, if you're getting into the business, you need to be thinking about the fact that you're still going to have IPv4 capability. Even if you're putting in an IPv6 network, your customers are still going to need an address, access to an address or their own address, whether that's through carrier grade NAT or, again, every customer having their own address. You're still going to need to do that. So you might want to look now at the best way to do that, and carrier grade NAT is the way to go. You don't want to spend the next 5-10 years buying IPv4 addresses as your business grows. That's my opinion. Okay. So thanks for joining me. I appreciate it for Tech Tuesday. I'll be back tomorrow for broadband deployment news. So if you're not subscribed, click the subscribe button, click the little bell on YouTube to be notified when I'm live. If this was interesting or helpful for you as far as IPv6 and IPv4, if you'd give me a like on the video, I'd appreciate it. Thanks a lot. I'll see you tomorrow for broadband deployment news. Bye-bye.